Hello students, feels good to be back. Welcome to LFI Educates. Today we will start a new chapter, energy. We will be learning about using energy, chemical stores of energy, more energy stores, thermal energy, kinetic energy, energy on the move, energy changing form, and energy is conserved. So let's get started. Using energy. We need energy for everything that we do: walking, lifting things, and playing. We know that we get our energy from the food that we eat. Where do machines get the energy from? Aeroplanes, cars, and buses get the energy from fuels. Electricity also helps us by providing energy. It is produced in large power stations and brought to our homes through metal cables or known as wires. So we can say that we need energy supply to make something happen. Chemical stores of energy. When fuels are burnt, they release the energy stored in them, which is used to make things happen. A battery is also a source of energy. The energy is given out when it is connected to a circuit with a device, which uses the energy. Food, fuels, and batteries are all stores of energy. They are made up of chemical substances. We say that they are chemical stores of energy. Burning of fuel such as petrol or gas is a chemical reaction. To get the energy from the food, a chemical reaction takes place inside a body, and inside the battery there are chemicals which react to give out electricity. More energy stores. Apart from fuels and batteries, there are other sources of energy as well, such as a spring used in a clock or energy stored in a raised object such as a hammer. You must have noticed there are some clocks and toys that do not need batteries. They have a key which can be wound up and the clock or a toy starts working. Or you must have played with a car toy that will go forward after you pull it back. All of these work with the help of the energy stored in the spring, which is inside the object, which collects the energy. When you wind it or pull it back, we give the energy from our hand to move the key or pull it back, and the spring takes this energy and stores the energy as elastic energy. When it gets stretched and releases it, it comes back to its original unstretched position, causing the object to operate. A hammer is a heavy object. When we lift a hammer, we apply some energy from our body, and it has to overcome the force of gravity which is pulling it downwards. So the raised object is a store of gravitational potential energy. The higher the object is raised, the more energy it will have. Thermal energy. If we heat something, it gets hot. We say that it is thermal energy store. The hotter it is, the more energy it stores. We use thermal energy to cook food. A fuel or a battery stores energy for a long period of time, but thermal energy is not like a fuel or a battery. The energy spreads out into the surrounding and loses its energy. This is the reason why a hot cup of tea will cool down after some time when it is left in the open, as the energy spreads from the cup to the surrounding. Kinetic energy. A moving object has kinetic energy. When we ride a bicycle, we use our energy to push the pedals and the cycle moves. When the object stops, it does not have kinetic energy. More the speed, the kinetic energy will also be more. If the mass of the object is more, then it will have more kinetic energy than the lighter object moving at the same speed. So what happens to the kinetic energy when an object stops? For example, when we are riding a bicycle and apply the brakes to stop the cycle, the brakes block the wheel and the cycle stops. The force of friction between the brakes and the wheel stops the cycle, so the kinetic energy is transferred to heat energy due to friction, and the brakes gets hot. We have learned in our previous lesson that friction slows or stops an object. So friction reduces kinetic energy and makes things hotter. Energy on the move. Energy can be transferred from one object to another. In a battery connected to a lamp, the energy from the battery gets transferred to the bulb, so the bulb gives out heat and light energy. To transfer the energy from the battery to the bulb, we connect it with the wires. So wires carry energy to the bulb. Heat energy spreads out from the source to its surrounding, which is cooler. If an object is very hot, it will glow and give out light energy. The light energy also spreads out in all directions. Similarly, sound energy is also transferred from its source through air. When we bang a drum, we can hear it as the energy from the drum is transferred to our ears through air. Energy changing form. We need energy to make things happen. Energy can be stored in different ways. Energy can be transferred in different ways. Chemical energy. Energy of a chemical substance. Elastic energy. Energy of a stretched or squashed object. Electrical energy. Energy carried by electricity. Gravitational potential energy. Energy of an object that has been lifted. Heat energy. Energy spreading out from a hot object. Kinetic energy. Energy of a moving object. Light energy. Energy spreading out from a bright object. Thermal energy. Energy of a hot object. Sound energy. Energy coming out of a vibrating source. Energy can be transferred to change its form. For example, in a radio, electrical energy can be changed to sound energy, and in a TV, electric energy is changed to sound energy and light energy. Energy is conserved. We measure energy in the units called joules. The shorthand for joules is J. Energy cannot be created or destroyed. It can only be changed from one form to another. This is the principle of conservation of energy. If a machine is getting 10 million joules energy from a fuel, then it will be transferred to 5 million joule as work and 5 million joules as heat. Similarly, in a torch, the energy gets transferred to light and heat energy. The unit in which we measure energy is named after James Joule, who made important discoveries about energy in the 19th century. This is all in the chapter. More videos are on the way. Till then, take care. Thank you.